Ever get that feeling like you're drowning in information? You just want the good stuff, right? The insights that really make a difference.
Uh-huh, moments, without having to wade through a sea of data.
Exactly. Well, that's what we do here on the Deep Dive. We take those complex topics and we dive deep. And today, we're tackling something that I think we've all thought about at some point. Whether we're the ones learning or the ones trying to teach it, how do you know, really know, if someone is actually engaged?
Ah, the age-old question.
Yeah. And you guys sent us this fascinating article, Attentive or Not, toward a machine learning approach to assessing students' visible engagement in classroom instruction. Quite a mouthful.
It does have a certain ring to it.
But what we really want to explore here is this idea. Can technology, and specifically machine learning, give us a new way to look at engagement?
I think it can. And I think it's a question that resonates with a lot of people, right? Whether you're a student trying to figure out how to improve your own focus, a teacher working to make sure your students are with you, maybe you're prepping for a big presentation and you need to read the room.
Or maybe you're just interested in how learning works, period.
Right. Because understanding engagement, it's really the foundation for learning and teaching to be effective.
It's funny, though, because on the surface, it seems pretty straightforward. I mean, most of us can tell if someone's completely checked out, right? Like they're daydreaming or something.
It seems like it should be obvious.
But if you're a teacher with a whole classroom of students,
Or a researcher trying to collect data.
yeah, how do you actually measure that in a way that's useful? And that's where it gets tricky, right? Because manually trying to assess engagement, that takes a lot of time and resources, especially for researchers or if you're doing in-depth teacher training.
Oh, absolutely. Imagine you're watching hours of classroom footage, painstakingly noting down every little detail of student behavior.
Yeah, I'm already exhausted just thinking about it.
It's a massive undertaking, and it requires expertise to interpret those behaviors correctly. So what's fascinating here is the possibility that machine learning could offer a shortcut. It could be like our own deep dive for engagement analysis.
I like that.
It has the potential to identify those key visible signs, those moments that really tell us if a student is connecting with the material or if they're drifting away. And that's precisely what this study is trying to do.
Okay, so the article we're diving into today starts by talking about how teachers are constantly observing their students, trying to gauge their level of engagement. Why is that constant observation so important for good teaching?
Well, if we think about those elements of good teaching, the article highlights things like cognitive activation, which is essentially getting students to really think deeply about the material.
Right, getting those brains working.
Exactly. And then there's effective classroom management. So maintaining order, keeping everyone on track,
Keeping the chaos at bay, I imagine that's a challenge.
especially with a room full of kids.
For sure.
But an engaged student or a disengaged student gives you important clues about both of those things. So are they actually processing what's being taught? Are they focused? Are they on task?
Because a room full of disengaged students is a pretty clear sign that something's not working.
It could be a sign that the lesson needs adjusting. Or maybe there are distractions that need to be addressed.
Right. I guess someone staring out the window probably isn't thinking deeply about quadratic equations.
Probably not, no. But as the article points out, spotting these cues can be a bit tricky, especially for teachers who are just starting out.
So for newer teachers, it's not always that easy to keep track of an entire classroom of students.
Right, and to pick up on those subtle signs that someone's engaged or losing focus. It's definitely a skill that develops over time with experience.
Like anything else, you get better with practice.
Absolutely. But that's where better ways to measure student attention can really be valuable, both in terms of helping us understand learning better, but also in improving how we train new teachers.
So traditionally, teacher training and educational research have relied a lot on watching videos, haven't they?
Yes, video analysis has been a staple both for helping teachers reflect on their own practice and for researchers who are trying to understand what's actually happening in classrooms.
So teachers can watch recordings of themselves teaching, see what went well, see what they could improve.
Exactly. And that includes how they were responding to or managing student engagement. Researchers use video to investigate the relationships between teaching practices and student outcomes. And of course, attention is a big part of that.
But like we were talking about earlier, this whole process seems incredibly time-consuming.
Oh, it is.
And I imagine it takes a lot of resources as well.
Yes, absolutely. To really do it well, first you have to find those key moments within hours and hours of footage.
Yeah, that alone seems like a challenge.
Right. Then you have to code everything. You have to label what the students are doing. And to do that reliably, you need trained experts.
So that becomes a real barrier if you want to look at student attention across an entire lesson, or if you're trying to analyze this for a whole group of students.
And as the article mentions, this difficulty in obtaining and labeling the data is one reason why we haven't seen as much research into attention and engagement in real classroom settings as we might like. Because those messy, real-world classrooms can show us a much wider range of behaviors than we might see in a controlled lab environment.
Which brings us back to the potential of technology,
Ro-
because the article talks about how computer vision and machine learning could provide a solution.
Mhm.
Can you walk us through the basic idea here?
Sure. The idea is to basically use computers to automate the process of recognizing those visible signs of student engagement. So computer vision techniques can analyze video, and they can extract information like where a student is looking, the angle of their head, even their facial expressions.
Really?
Yeah. And then machine learning algorithms, these are trained to recognize patterns in those visual features that are associated with different levels of engagement.
Based on comparisons to how human experts have already coded those behaviors.
Exactly.
So the computer's basically learning from the humans.
Hmm.
And the main goal of this study we're looking at was to see if this automated way of assessing attentiveness could be a reliable indicator of whether a student is actively engaged in learning.
Yes, that's the big question they're investigating.
So can technology give us a more efficient and more scalable way to understand when students are really tuned in?
Exactly.
Now, the article makes this really important distinction between attention and engagement. And those two concepts seem related, but I think they're distinct.
They are distinct, and it's really important to make that distinction. The authors explain that while we often use these words interchangeably, attention is actually just one component of what we call behavioral engagement.
Okay.
So in cognitive psychology, we think of attention as a kind of filter for information. It decides what gets into our short-term memory. So you can think of it as a gatekeeper that helps us not get overloaded by all the sights, sounds, and sensations bombarding us all the time so we can focus on what's important. And only the stuff that gets through that attentional filter can then be processed, organized, and connected to what we already know.
So if you're not paying attention,
Then the learning can't really begin.
you're not even at the starting line.
Right. And some researchers even argue that actively focusing on or blocking out information in our short-term memory, something called executive attention, is a particularly important part of this.
Okay.
And it's especially important when we're learning something that requires us to shift our focus, ignore distractions, or update what we're thinking about. So while these attentional processes are mostly internal,
Right. They're happening in our brains.
right, some aspects of them are actually visible, like looking toward something. And that can give us a clue as to where someone's focus is directed.
Right. So if I see you looking at your phone, I can probably guess that you're not paying attention to me. Okay, so attention is this internal filtering process, but how does engagement build upon that?
So engagement is a much broader concept, and it has multiple components.
Okay.
The article describes it as being crucial for learning and for academic achievement. And it involves not only what we see someone doing, but also what's going on in their minds and how they're feeling.
Right. So the whole package.
Yeah. Cognitive engagement is all about those internal mental efforts, like trying to understand a complex idea. Emotional engagement includes things like excitement, interest, but also boredom, frustration. And then there's behavioral engagement, which, like we said, includes observable things like participating in class, behaving appropriately, persistence in the face of a challenge. And like we said, paying attention is considered a part of this behavioral component.
So in theory, you could be behaviorally engaged. Like you're sitting up straight, you're looking at the teacher, but you're not really mentally engaged.
You're just going through the motions.
Right, exactly. You're not putting in the mental effort, you're not feeling that curiosity, and you're not really absorbing the material.
And that's why just looking at behavior isn't always a foolproof way to gauge true engagement, but it's often the best starting point.
Especially in a classroom setting.
Exactly.
Okay, so the article then dives into how people have tried to measure engagement in the past, and it sounds like it's been a pretty tough nut to crack.
It has been, yeah. And a lot of that difficulty comes from this fundamental challenge of trying to understand those internal thoughts and feelings,
Right, that internal world.
based purely on outward behavior. Now, in psychology labs, researchers can use things like heart rate monitors, eye trackers, or even EEG, which measures brain waves.
So they're trying to get more direct measures of what's happening in the brain.
Right, they're trying to peek inside. And while these methods can provide really precise data, they're just not practical for everyday use in classrooms.
Right. Can you imagine trying to hook every student up to an EEG machine?
Every day.
It would be chaos.
So in classrooms, we really have to rely on what we can observe. And while it's not a perfect reflection of what's happening inside someone's head, the article does highlight that student classroom behavior has been shown to be an important predictor of academic achievement.
So what we see students doing does seem to be connected to how well they learn.
There's a link there. And previous research has looked at specific behaviors and found relationships to how well students perform.
And the article brings up a few specific concepts here, like this thing called the IECAP framework. What is that exactly?
So the ICCAF framework, which is developed by Chi and Wiley, gives us a way to categorize different types of observable behavior based on how much mental engagement they seem to reflect. It talks about passive, active, constructive, and interactive behaviors. So, for example, simply listening to a lecture would be considered a passive activity.
Okay,
Taking notes would be considered active.
gotcha.
Summarizing information in your own words is constructive. And then discussing ideas or working on a problem with others is interactive. And that's generally considered the most cognitively engaging type of behavior.
So this framework emphasizes that just because a student looks like they're on task doesn't necessarily mean they're really digging into the material.
Exactly. They might be physically present, but mentally checked out.
But the article also mentions that there's been a gap in research. What hasn't been studied as much?
They point out that there haven't been a lot of studies that look at attention or engagement continuously over the course of a whole lesson.
Okay.
So most studies have relied on just taking snapshots of behavior or on asking students to remember how engaged they felt after the lesson was over. And what's new about this particular study is that they were aiming to capture those changes in engagement in real time. So a score for every student, every second.
That's a very granular level of detail. How did they pull that off? I mean, it sounds incredibly labor-intensive.
Well, they developed a new manual rating instrument,
Oh.
specifically designed to allow for continuous annotation. They used a software platform called Karma, which allows you to code behaviors over time, kind of like using a joystick to track those changes.
So they're not just looking at categories of behavior.
Right. And a lot of the existing rating systems use these broad categories. They don't provide second-by-second detail.
Right.
So the researchers had to create their own.
Okay. So they were building on previous methods, but really focusing on capturing those subtle shifts in visible behavior.
Exactly.
So what did this new rating scale actually look like? What were they looking for?
Well, the scale ranged from -2 to +2. So at the -2 end, we're talking about disruptive off-task behavior.
Like throwing paper airplanes or something?
Well, hopefully not that disruptive,
Okay.
but definitely not paying attention to the lesson. At the +2 end, you have highly engaged on-task behaviors. So things like asking insightful questions or maybe explaining a concept to a classmate. And in between those extremes, you had various levels of on-task and off-task behavior.
Okay, so it wasn't just a simple paying attention or not paying attention. It was a whole spectrum.
Exactly. It was designed to capture the nuances of what they were seeing.
And how did they actually use this scale to analyze those videos?
So they had a team of trained coders. And these coders would watch the videos and they would continuously code the behavior of each student they were observing
Every single second.
every single second
Yeah.
using that joystick and Karma software.
Wow. That sounds like a lot of work.
Oh, it was a huge undertaking. And they were specifically instructed to focus only on what they could see. So no guessing about what a student might be thinking or feeling, just observable behavior.
Okay.
And to ensure consistency, each video was actually rated by multiple coders. They went through this whole training process to make sure that everyone was using the scale in the same way, that they were interpreting those visual cues consistently.
Okay.
And they even calculated inter-rater reliability to see how well their ratings agreed.
Which means they're checking to make sure that if two different people are coding the same behavior, they're giving it roughly the same score.
Exactly. And if there were big discrepancies, they would discuss those segments and they would recode them until they reached an agreement. So this very detailed manual coding was considered their gold standard. It was the baseline data that they then used to train their machine learning tools.
Okay, so a ton of manual work went into laying the groundwork.
It did.
Then, after all that manual coding, they transition to the machine learning part.
Right. So the idea was to see if they could use the power of machine learning and computer vision to essentially automate this really time-consuming process.
Okay.
Machine learning algorithms are very good at recognizing patterns, and they can be trained to pick up on patterns in those visible cues of engagement that we've been talking about.
Mm-hmm.
So things like head position.
Mm-hmm.
Is the student looking at the teacher? Are they looking at their notes?
Mm-hmm.
Gaze direction, facial expressions, even body posture can be informative.
Mm-hmm. So the computer is basically analyzing all those nonverbal signals that we as humans might pick up on subconsciously.
Exactly.
And the article talks about two main approaches to this automated assessment. One is looking at a single person,
Mm.
and the other is looking at the classroom as a whole. What's the difference there?
So when you're analyzing a single person, the focus is often on the face. Researchers use things like facial action units, or AUs. These are basically the tiny muscle movements that create our facial expressions.
Okay.
So by analyzing these very subtle movements, the machine can try to infer how a student is feeling.
Right, because we tend to express our emotions through our faces.
We do. Now, the article does point out that a lot of these single-person analysis methods don't take into account head pose or gaze direction, which are also really important indicators of attention.
Right, so you could be smiling, but your eyes are glazed over and you're staring off into space.
Exactly. So, classroom-based analysis, on the other hand, looks at the bigger picture. It's focusing on those shared features or interactions happening within the classroom. So things like movement or synchronized motions.
Okay. So if everyone in the classroom suddenly looks up at the same time, that probably means something significant just happened.
Exactly. And previous research in this area has looked at how students sitting near each other might influence one another's attention,
Interesting.
or whether there's a relationship between how our students move around and their self-reported levels of attentiveness. Some studies have even used those special 3D cameras or looked at the synchrony of head movements between students.
Wow. So they're really trying to capture the dynamics of the whole classroom.
They are. And it can be really challenging because classrooms are very dynamic environments.
Yeah, they're not controlled lab settings.
No. The lighting changes, students block each other, they might be far away from the camera. And the article highlights that recent advances in deep learning, which is a type of AI, have really helped to overcome some of these challenges.
Okay. And the thing that this study is really contributing, as they point out, is that they were looking at these visible signs of engagement in a really fine-grained way. And really importantly, they also considered this idea of classroom synchrony.
Right. So they didn't just analyze each student's head pose, gaze, and facial expressions in isolation, but they also looked at whether those behaviors were synchronized with students sitting nearby. And they wanted to see if that could improve the accuracy of the automated assessments.
Okay. So they were basically asking, can we get a better read on a student's engagement by also looking at what their neighbors are doing?
That's a big part of it. And the article lays out the specific research questions that they were trying to answer with this approach.
Okay. So walk us through the actual study. What did they do and what did they find?
So their participants were university students.
Okay.
And the setting was a series of seminar classes focused on statistics.
Sounds riveting.
Right. And they video recorded 3 different seminar sessions.
Yeah.
In addition to the video data, they collected information on the students' prior knowledge of the topic. They gave them a knowledge test afterwards. And they also had the students complete questionnaires about how they felt during this seminar.
So they're getting at those internal states like cognitive engagement, how involved they felt, and how interesting they found the material.
Exactly.
And we've already talked about how they painstakingly coded the videos manually. But on the machine learning side, what kind of visual features was the computer analyzing?
So on the machine learning side, they use computer vision techniques to detect faces in the videos. And then they automatically extracted features using a software library called OpenFace. These features included things like head pose, which is the position and direction of the head, where each eye was looking, and also facial expressions. And remember, those facial expressions were represented by those facial action units. So basically measurements of the specific muscles that are involved in making those expressions. So they have this wealth of data now. And to analyze it, they use something called regression models. And this is basically a statistical technique that tries to predict the manual engagement ratings based on those automatically detected features.
Okay.
So they're training the machine to see if those visual cues can actually predict what the human coders observed.
Right. They're essentially asking, can the computer learn to see engagement the way a human would?
Exactly.
So they have 2 sets of data, the human ratings and the computer's analysis. What did they find when they compared them?
So first, they wanted to make sure that those manual ratings were actually measuring something meaningful.
Right. They had to make sure those human coders were on the right track.
Exactly. And thankfully, they did find significant correlations between those manual ratings and the students' self-reported engagement, involvement, and interest, which suggests that the coders were indeed picking up on relevant aspects of student engagement.
Okay, good. So the humans were doing their job well.
They were. And really importantly, they also found that the manual readings did a pretty good job of predicting how well the students did on that knowledge test at the end, even after controlling for what the students already knew coming into the seminar.
So the students who were rated as more engaged, according to those manual ratings, tended to perform better on the test.
They did. So this gave them confidence that their manual ratings were a good benchmark, a good standard to compare the machine learning results against.
So how did the machine learning models stack up against those manual ratings and against the actual learning outcomes?
Well, they found that the machine learning models that use both head pose and gaze, or all three, head pose, gaze, and facial expressions, had pretty good correlations with the manual ratings.
So the computer was starting to get a decent read on engagement, at least based on those visual cues.
It was. And interestingly, they also found that the models that did a better job of matching those human ratings also tended to be more relevant for predicting how the students felt afterwards, particularly their involvement and cognitive engagement, according to those questionnaires.
So the visual cues that the machine learning models were focusing on actually seemed to be related to how those students were experiencing the learning process. That's really neat.
It is. It suggests that the computer's not just picking up on random movements. It's actually tapping into something meaningful about the student's internal state.
What about the idea of students behaving in sync? How did that play out?
So remember, they measured how similar the manual engagement ratings were for students sitting at the same desk.
Right.
And they found that that similarity, so how in sync those students were, was strongly related to their average engagement levels.
So if your neighbor's engaged, you're more likely to be engaged as well.
It seems that way, yes. And when they added this information about neighbor synchrony to their machine learning models, it actually improved how well the automated estimations matched those manual ratings. And it also led to better predictions of the students' self-reported feelings and their performance on that knowledge test.
So taking into account what's happening around a student, not just what they're doing individually, can help the computer get a more accurate picture of their engagement level.
Exactly. It really highlights the importance of that social context. But it's important to note that while the automated approach showed real promise, the manual ratings were still slightly better at predicting those learning outcomes.
So the human eye, or the human coder, still had a bit of an edge.
For now.
Okay, so let's move on to what the researchers made of all these findings. The article highlights that they found empirical support for their new manual rating instrument, which is a really important first step.
It is. It means they have a reliable way to measure engagement that can be used to train and evaluate those automated systems.
Right, so that groundwork is solid.
Yes. The fact that these ratings lined up well with the student self-reports and were able to predict learning outcomes gives us confidence that they're capturing something real. The authors also point out that while facial expressions on their own showed a decent correlation with the manual ratings, it was really the combination of different cues, so the head pose, gaze, and facial expressions, that led to those strong correlations in the automated approach.
Which makes sense because when we as humans are judging someone's engagement, we're looking at the whole picture, aren't we?
We are. We're subconsciously integrating all of those signals. And that's something that these machine learning models are getting better at doing.
So what do they see as the big advantages of this automated approach, assuming it continues to improve?
Well, the potential here is really exciting. First off, it could drastically reduce the amount of effort involved in analyzing classroom videos, both for researchers and for teacher training purposes. Right now, people are spending countless hours doing this manually. But if we can automate that process, it frees up time and resources. It also allows researchers to analyze much larger data sets and to look at learning over longer periods of time.
Okay.
Second, and this is really interesting, computers might be able to pick up on really complex patterns of synchronized behavior in the classroom that a human observer might miss.
Okay.
We just don't have the capacity to process all that information in real time.
Right.
But a computer can.
The article also mentions how this automated approach could be really beneficial for teacher training. What are some of the ways they suggest it could be used?
Well, first of all, it could provide teachers with feedback on their own ability to monitor student engagement.
Okay.
So are they missing cues? Are they picking up on the right things? It could also show teachers how student engagement levels fluctuate over the course of a lesson,
Interesting.
which might prompt them to adjust their teaching, either in the moment or in future lessons. So it could be a really powerful tool for reflection and professional development.
Right, because if you see that engagement dips at a certain point in the lesson, maybe that's a signal that you need to change things up.
Exactly. And this kind of feedback could really help teachers develop what we call professional vision, which is that ability to notice and to understand the really important things that are happening in the classroom.
And for research, it seems like this could open up a lot of new possibilities as well.
Oh, absolutely.
Hmm?
Being able to continuously track engagement would allow researchers to really investigate the dynamics of classroom instruction.
Okay.
So, what events or teaching practices lead to changes in engagement and why?
Right.
And they can start to untangle those cause and effect relationships. The authors also suggest that combining this automated approach with other tools like eye tracking, both for the students and for the teacher, could provide even richer insights into how teaching and learning work.
So we're talking about a pretty significant shift in how we study education.
It has the potential to be, yes.
But like with any new technology, there are always going to be challenges. What did they identify as some of the limitations of this particular study?
So one big one was with the face recognition part, because sometimes students would block each other or they would be looking down at their desks.
Right.
And the computer couldn't always reliably detect everyone's faces, which means they ended up with less data for the automated analysis,
Okay.
which could have affected their results. And they suggest that using cameras from multiple angles in future studies might help with this.
So we're talking about having multiple cameras in the classroom
Hmm.
to make sure you're capturing everyone's face.
Right.
Okay, what were some of the other challenges?
Another issue was that in this particular study, remember they were looking at university students in a statistics seminar.
Yeah.
Most of the engagement ratings ended up being kind of in the middle of that scale.
Okay.
So they didn't have as much data on those extremes, students being either super engaged or totally checked out. And this imbalance in the data can make it trickier to train machine learning algorithms effectively.
Right, because those algorithms need lots of examples across the whole spectrum to really learn the patterns.
Yeah.
So they need to see what high engagement looks like, they need to see what low engagement looks like, and everything in between.
Right.
So the researchers suggest that recording a wider range of classroom situations, maybe in different types of schools, could help to address this issue.
Mm-hmm.
And of course, the study was done with university students.
Right.
And the authors acknowledge that more testing needs to be done in actual K-12 classrooms
They do.
because students in different settings might behave differently.
Exactly. And younger students, especially, might show a much wider range of engagement behaviors. So it's important to make sure that their approach works just as well in different educational contexts with students of different ages.
All right. So as we wrap up our deep dive into this research, what's the key takeaway about machine learning and its potential for assessing student engagement?
I think the main takeaway here is that machine learning is showing a lot of promise when it comes to automatically picking up on those visible indicators of student engagement. It offers a potentially more efficient and more nuanced approach than relying solely on traditional manual methods.
So it's not a replacement for human observation yet, but it's getting there.
Exactly.
And the technology is clearly advancing.
It is. And while the current automated systems might not be perfect, combining those different visual cues, the head pose, gaze, facial expressions, and importantly, looking at how students' behaviors are synchronized with one another is significantly improving the accuracy of these systems.
And that has some pretty exciting implications for the future of education,
It does.
both in terms of research and in terms of what this could mean for teachers and students in the classroom.
Absolutely. It could revolutionize how we study learning.
Yeah.
And it could give teachers incredibly valuable insights into how their students are engaging with the material, which ultimately leads to more effective teaching and better learning for everyone.
It's really interesting to think about, isn't it, how we as humans judge whether or not someone's engaged. Whether we're in a classroom, giving a presentation, or even just having a conversation, we're always looking for those cues.
We are.
Eye contact, nodding, asking questions, and now computers are starting to be able to do the same thing. It really highlights how complex human interaction is and how far AI has come in trying to understand it.
It does.
It's definitely something to ponder.
It is.
Well, thank you so much for diving deep with us today. This has been a fascinating look into the world of automated engagement assessment. And a huge thank you to all of you listeners for joining us on this journey.
Thanks for having me.
It's been a pleasure. We hope this has given you some new food.